everyone. My name is Rohit, and I have my panelists today. Hi, Parth. Hi, Prabhu. So, Prabhu, a quick introduction from you, and then I will also introduce myself. I think we are already introduced. So, a quick about what you're doing today in terms of data specifically. We heard a lot about data quality being discussed. Uh, what are you doing today about AI, ML, on data integrations and how the data architectures you are developing? So we are not able to hear him.
Can you hear me?
Yeah.
Yeah. Sorry. Thank you, Rohit. Thanks for that question. I'm sorry to everyone that you have to bear with me in seeing me in such a zoomed out state. But Rohit, to your question about how data is being used and how is data quality is something that we're looking at. So predominantly, when you deal with systems like ERP or CRM and other systems, there are, these are much established systems, right? So governing data quality in them is pretty much kind of established, and there are some practices that you will have to follow to govern data quality. But in all the other new technologies and emerging technologies that we are implementing, starting with industrial IoT, be it artificial intelligence or machine learning, the amount of data that you have to deal with in these cases is very huge. So understanding what is wrong and what is right, that itself takes a lot of time for us. So
Correct.
we really have to spend time in trying to get to know the data and accustom ourselves to that data first, and then slowly understand what is an anomaly and what are not anomalies, what can I take. Many a times, it so happens that when you look at industrial IoT, data from industrial IoT, the data that you think is an anomaly is actually an insightful data that you will have to play around with and derive insights out of. So this learning takes some time, and it's not that I've done it in one project, in one initiative, so it'll be easy for me to do it in another one, because the nature of the data and the way it manifests itself is very different. So you will have to do that learning in every stage. It's just how fast you get to that learning phase and try to see how you can gauge data quality and improve it. That is the key here.
Yeah, right. So, Prabhu, what is your thought? So, I was just thinking about it maybe yesterday, and it's something that has dawned upon me today now, is the hierarchy in which the data is structured. So typically what happens is, as you rightly said, an anomaly detected is actually a good data point to ponder upon rather than thinking that it's a data problem, right? But if you can see this room today, right? So what is the hierarchy in which data structures are made is actually an example here. So four legs come together and make a chair, and then you add that a table in the center, and then you add four walls to this. You have Rohit standing here, you have Prabhu talking over here, then that makes this conference. You add another layer to it, then that makes this hotel, then you add more hotels, more airport, that Mumbai city. Then you keep on hierarchically going up, you can always go to the cosmos. Yeah? So my thought is that when we develop data structures, we should look at a hierarchy in which we are developing those data structures. We talked about bioscience today in the morning. Yeah. So this is the typical problem that I feel, that when the management gets pumped up to do new initiatives on AI and ML, we talk about AI and ML just like we say Ram and Shyam, but AI is different, ML is different. So a management should typically ask their data scientists and data engineers is if I'm doing an ML project, the question that should be asked is, what is the learning that this machine is taking? What is this learning that this machine is giving to us? If I am driving an AI project, the question that everybody should be asking is, what is the intelligence that the system is artificially driving? Correct? What's your thought on that?
Right. No, I think I liked your point about the hierarchy on the data structures, right? So if I look at it from a different perspective, this is one of the key learnings that anyone driving a digital transformation would come across, right? So when you look at digital transformation, organizations are busy in preparing a digital strategy and a digital roadmap and trying to understand where they will be next 3 years and so on. While that is definitely important, I think we will also have to look at it from the start small approach, where yes, you have a roadmap, you know what are the initiatives that you want to go towards, but start small and try to understand what are the initiatives, what are those that you can immediately kick off and show some results in. That increases the appetite for success as well within the team and within the business stakeholders and so on. And that also gives you a fair handle into the data that you're trying to acquire in those small initiatives. So as you build these initiatives, so maybe you start small, even when you do industrial IoT, you don't necessarily have to go gung ho and say, okay, I will, connect all the machines in the plant, and I'll try to see what data it throws up. That's not a good approach to begin with. Instead, if we say, okay, I will connect, there are these machines that really impact my production. So can I connect only these machines? And even that machine gives me 1,000 parameters. Can I look at only the operational parameters or the quality related parameters or something like that? The nearest use case that you have, which you can materially deliver, take that, build that, and have the data scheme ready for that. Because gone are the days when you plan for a year or 2 years and then have a data scheme, or develop a data architecture, and then go about implementing it. I think now we will have to take on as it comes. So take that data, implement that data, and then move to the next use case. Slowly build your data structure and your hierarchy, and then deliver, think about the larger picture, and then tie all these use cases together, deliver a larger picture. I think that would be the best approach to go, and I think that is the one that many of the people who are doing our transformation right now are following.
That's pretty right. So I absolutely agree with you. This is a problem that when we do something, we face. So pretty aptly said, Parth here, that people nowadays think that I want to create a data lake. I want to make a data lake. Just like that. I want to do digital transformation, just like that. But the sense that you are actually mentioning is the right thing, that you start with a pilot project, understand your data first, right? So somebody who's working on a data project should understand each and every column, each and every row that is there in the data. Then you bring 2, 3 use cases together. How do you bring that is also a very important question to answer. Yeah, I completely agree with you that it's not a fab. It's not something that I want to do digital transformation, I will start on it. So we saw today, there was a slide just before this might be talking. There was a word mentioned there, PCA, Principal Component Analysis. So what is that? So my sense is, I'm not going to answer that question here, but my sense is if we are working on a digital transformation or a machine learning project, if we are starting that, it is very, very important that you don't run that race alone. You have business folks with you, you should give them a training on what you are going to do. Now, the catch there is, which we experienced personally, it's an experience that the moment you start these, if you ask a room that, do you want to do a machine learning project or machine learning course, everybody would say yes. Now, the moment I would say it comes to the real mathematics, then there is a 90% attrition from people who are attending those machine learning courses. So the sense is, don't run that race alone, right? But it's more about you taking those business folks along with you so that they appreciate what machine learning models you're using. If you just say PCA and I'm doing a principal component analysis because I want to reduce noise in my data, or I want to find a trend because I have multiple dimensions in my data, what is that? Nobody would appreciate that. So it is very, very important that we take the business folks along. So Parth, what's your take on that in terms of training our business users to really appreciate what we are doing?
So in fact, many of the, like you rightly mentioned, right? So if you take a poll of the most abused words in digital transformation, I would say that is data lake, right? So data lake is the most abused word, and everyone wants to say, okay, can I create a data lake immediately? I mean, that's not a silver bullet which will solve all your problems. In fact, that has enough potential to add on more problems to you than solve, right? So what we have to do is, before we start something, most of these emerging technologies, be it artificial intelligence, machine learning, or augmented reality, virtual reality, blockchain, so all of these technologies are jargons for business folks at this moment, right? So, and there are a lot of misinformation being spread about these technologies to business folks. So they come into the room with a preconceived notion about these technologies, which most of the times is incorrect. So we will have to, first clear up that air there. And, maybe the first thing that we do is, at least this is something that we follow in our organization. The first thing before we start any initiative, even before we talk about it or try to conceptualize it, what we do is we have a technology familiarization session with the business users. So say, for example, if we think that, this use case is all about data, or is it about, if it's about machine learning, or maybe I'm trying to bring in augmented reality into it, or maybe there is a 3D visualization that's coming up. So we try to explain them about the technology without talking about the use case first. So we bring in folks from the industry who can talk about what they have done in their domain about these technologies and how the technologies have added value without going in depth into the actual technology part, just understanding the technology and what benefit it delivers. So once we are able to do that, that clears most of the misconceptions that people already have. They begin to unlearn, because right now, any new technology, first before you learn, you have to unlearn a lot of things.
Correct.
So that unlearning process is very crucial. When you come in with a preconceived notion, no matter what the amount of learning that gets to you, you don't get the right picture out of it. So that unlearning process is what we do in the tech familiarization sessions. And then we take them into a small, if it's AI, there are, multiple courses that offer them business for AI, AI for business kind of courses, where you understand the contours of AI and what is required from the business perspective to know artificial intelligence, for example, and then move forward. And when you want to say that this is the use case I want to solve using AI, what should be the considerations that you should be looking at before you pick a use case? These are things that the business user does not understand very easily. And I don't blame them for that, because they have not been exposed to it so far. So going forward, this is something that you will need to provide as an understanding to them first. Clear their mind about preconceived notions, set the context about what the data can do or what the technology can do to them, what it can deliver to them, and then start on the particular use case. Slowly work on that use case with them. So it's not that you look at the use case, you say that, okay, this is the solution, this is the challenge, this is the solution, I'm going to deliver this to you. We need their commitment on that. We need them to arrive at the solution along with us on that.
Correct.
So that is important for me.
Well, another thanks part. So another use case that we got approval maybe in the I would say the verbal approval yesterday was when so I just want to give you a hint on it. So another e-commerce player, I don't want to name that. What they did way back, 5 years back, was that they have all the label data. So the kind of T-shirt that they were selling, they had all the label data. Who is buying that? Demographics, age. You can talk about it. What kind of color of T-shirt that I'm selling? What are the other features? So they had that label data. What they did was they created a bot. So the job of that bot was to come up with a new design altogether, which would sell the maximum. So we maximize sales by giving new design. That was the idea. So if you would have worn or you would have seen a T-shirt which has a V-neck and a small pocket here, which pocket is a useless pocket, in fact. So that was the first of the designs that that bot made. Now, when I applied that learning to the pharma context, what I pitched in yesterday was an idea of an e-detailing. So a doctor, whenever a doctor is approached by a medical representative, he goes with an iPad today, and he shows, this is my brand, this is my product, why don't you prescribe that? There are RCP audits and everything aligned with it. So the idea is that this e-detailing, how much is the brand recall from that e-detailing? So there is font, there is color, there is texture, there is so many things. We can create those features out of it, and then come up with a score for each and every division that your e-detailing, the matter that you have, this is the score, and it needs to be improved in this area. And going forward, maybe when this whole model matures, when we develop this, is the idea is that AI in itself creates those e-detailing features so that the score is 10 on 10. So that's another pilot that we would be starting pretty soon. But yeah. So
yeah, no, I think
any ideas? So as I just mentioned it. So can you give us sudden insights on the kind of pilots and kind of AI or machine learning projects that you are actively pursuing and asking your management to work on?
Right. So that's very interesting that you spoke about how you are using the technology, the augmented reality technology in terms of retail, and how do you push that to the customer, right? So there's something very similar that we are doing. In fact, this we call this the augmented reality based machine fitment analysis, where as part of our organization's deliverables, we manufacture machines that are used by pharma companies, right? So these machines are sometimes installed in brownfield areas where there are other machines quite close to it. There is already a factory, and you will have to get this machine into that factory, install it there. So the whole process of trying to see uh, where are the conflicts and where are the places where the machine would actually not fit, or maybe the duct, how far the duct will have to run to get to the nearest output or nearest outlet, or things like that is something that we will have to understand. And these are traditionally done in a paper and pen method where someone notes these down, going to the customer's location, and this is very subjective. So he comes back and he delivers that to the design personnel, and he does the design based on what he understands from the notes that the agent prepared, right? So what we are doing right now is we are trying to bring in augmented reality, and we are putting the whole machine, the life-size machine, within the iPad that the person visiting the customer's location carries with him. So he gets the iPad, he looks at the brownfield project and places the machine life size in the location where it has to be, using the app on the iPad, and also draws the ducts, uh, snaps on various components that needs to be snapped onto the machine, analyzes conflicts, looks at the distances and things like that. So at the end of the day, he has a complete map, a real 3D map of how the machine fits into the customer's location, and where are the conflicts that they will have to address, or where are the re-engineering that they will have to do on the machines, what's the retrofitment that they would need. So all these are available at one go instead of having to do this in multiple iterations using the pen and paper method. So saves time, saves cost, and saves a lot of visits and manpower utilization from both the customer and our side. Apart from that, one interesting thing that we are also trying to do is, that we are world's largest manufacturer of, second largest manufacturer of empty hard shell capsules. And the quality of these capsules is of paramount importance to us. Although there is a machine at the end of the line which checks the dimensional attributes of the capsules and a lot of other defects in the capsules, like bubbles, holes, or loose rings, loose caps, loose body, things like that. What we do is we are trying to see, instead of waiting until the end of the line and then checking the output and then correcting the output, why don't I do it as it goes, as it moves, right? So in a real-time batch correction kind of fashion, where we are employing computer vision techniques to train the computer vision model to look at good capsules and bad capsules and categorize it into multiple defects, and always give a good understanding to the operators and the production people about what are the defects that are coming on the top right now. What percentage of the capsules are rejected because of what defects right now, so they'll be able to take immediate corrective action. In fact, what's on the cards is also to see how we can, once we point out a defect, how can I look at recommending corrective actions by looking at the past data of actions that people have taken based on the defects that have happened so far. And there are a lot of other cases where I'm using AI, like golden badge. AI will find a lot of use in supply chain related things, where we can bring end-to-end visibility in terms of starting from the supply side, from my, from the people who are my vendors, starting from their side, including the manufacturing for my factories, and the fulfillment where we deliver it to our customers and hand it over to them. So that entire end-to-end visibility is being brought, and we are able to do a lot of predictions, simulations, and things like that to do what-if scenario analysis to understand what would be the impact of any disruption to that entire chain, and how would I be able to recuperate from that impact or even mitigate that impact. So these are some very high level things that we are doing right now. I would definitely I would love to talk about these things and go on and on, but I know time is of essence. But so these are high level things that we are doing right now. And Rohit, I would also like to hear you from the perspective of sales and distribution. What is it that you have been doing from the perspective of AI or ML?
Well, Parth, thanks for bringing that up. The way, so another use case that I want to maybe share today is the way this modern trade, which we call as modern trade, is e-pharmacies of the world, are changing the landscape of the pharma world in terms of the reach out to the customer at the end, is something that we are really rigorously working on. So what happens today is, I don't want to name any e-pharmacy here, but let's take an example. So they purchase, say, 50 crores of inventory from Mumbai, and they sell it in Delhi. So what will happen is, so the incentive, the way it is designed in the sales structure of some pharma industries, is actually at the headquarter level. So if the Mumbai sales is happening of 50 crores, the incentive for that sale would go to the Mumbai guy, because the headquarter is that. But who created that demand in pharma space? So it's majorly around that, I said. So the MRs go, so the demand was created by somebody in Delhi, and the sales incentive was given to somebody in Mumbai. And this volume, if you look at just Sun Pharma, is in three digits of crores every month. That is the volume of the data. So what we did was, we created a system, automated system of sales credit adjustment, wherein all the data that comes in. So there was a lot of work. It took us around 1.5 years to streamline that quality of the data there. And now we are at a place where this whole process of sales credit adjustment gets done like this. Now, once we did that, so the question that our management asked us was, Rohit, we feel that there is something which is not correct in the way the data is being shared with us. Can you do something around it? So that was the birth of a project called, we do it as Detect X, which is to identify, with which we started our discussion. Can we identify certain patterns in the data which are anomalous, and can we do something about it? So that was what we started with this whole initiative. Now what we're doing is bringing in our primary sales, bringing in our secondary sales, and the sales of the modern trade partners, all of this together to find trends and patterns which are anomalous, and then taking corrective action on that. Sometimes the corrective actions are at the stockist level, sometimes the corrective actions are even at our primary data level, and majorly they are around our modern trade partners. So that is what we're doing there in our supply chain side and distribution side part. With that, I think you have anything else to add here? But we were just randomly, this just was not a paired discussion. So any passing comments from you before I close this?
Yeah, I mean, I think one of the critical things that we also have to touch upon in any transformation kind of a talk is about adoption, right? So how do you drive adoption? Because you could have a good technology, you could have a good solution, you could also have a solution that fits your challenge appropriately. But what is there to guarantee that people are going to use it, right? So how do you drive that? That's a very important thing. In fact, an example comes to my mind where this is something that we encountered live. This happened in one of the manufacturing companies that construction companies that I used to work for before, not now. So we did industrial IoT across all these equipments. Construction companies have these huge equipments like the tower cranes, the batching plants, the wheel loaders, the tower, the whatnot, right? So all these equipments are guzzlers of petrol. So if you have to look at savings of your petrol cost, the fuel consumption cost, even if we save 0.5% of the fuel that we consume in a year, that amounted to easily about hundreds of crores of savings in that company. That was the size. So to look at what we can do to it, we tried to do industrial IoT on these equipments, and we rolled out this solution. And we wanted to understand what is the pattern in fuel consumption, and where is the reason for pilferage of fuel and things like that, right? So then there was this one construction site where one of these equipments, the wheel loader, was there. And the data coming from the wheel loader was very suspicious to us, right? So because it was very, it was, I would say it was very accurate, right? So it was very correct, and this was so ideal that it can't happen. So we were a little piqued by that, and I wanted to go visit that place personally. So fortunately, that site was very close to the place of my living. So I went there and tried to understand. It's 7 a.m. in the morning. Went there, tried to understand what's happening. The wheel loader was already passing data to us. Work has not started, and the site was all empty. But wheel loader is saying that it's doing some work, it's consuming some fuel and things like that. So when I went located that wheel loader, it was running actually. It was idling, right? So I picked one person from there who was the supervisor, who was the in charge, and asked him, why is the wheel loader running? You're not, there's no work going on at the site, so why is the wheel loader running? So the answer that he gives me, puzzled me, right? So he said, no, वहाँ पे कुछ sensor लगा दिया है, और साहब लोग monitor कर रहे हैं So whenever the wheel loader is not working, they are going to call me and say, why is the wheel loader not working? So it actually worked counterproductive for us and said, it actually was the reason for guzzling even more fuel than we had planned. So we have to understand or make the ground level folks understand what the initiative is about before we even roll them out or before they even get misconceptions about their initiative through various sources. So we have to educate them on what is happening and what their role is towards that initiative, and then slowly take them to the fore. So this is something that was a hard learning for me, and I think although we learned this, every initiative provides me the same challenge in different forms and shapes. So this is something that we are still trying to look at how we can take the users along in the journey.
Thank you so much, Parth. I just would like to conclude our talk today with a very small story that I have which tells us about the evolution of data. So if you step out today out of ITC Maratha, which you will, if you see a small animal which is 2 feet in height, maybe this much long, has a long tail, and is barking, why do you call that a dog? It's something that which I can explain as a story. So why do we call that as a dog is essentially there was a time when this whole question was asked in this data science community. And then they understood that, okay, if we have to teach a machine that this is a dog, then let's get all the images of the dog together that are there in the world and put some good processing power on it, and it will identify that dog. So they built a vision, and what they did was, the moment it is going through those thousands and millions of images, and till the time it can identify that it's a dog, the dog has already gone by. So that was the time, if you remember, if you recollect, that robotics and this vision was creating a problem there. Then they said, okay, let's do one thing another. Let's go another step forward. Let's create features. So it would have a long tail, curved tail. It would have 4 legs. These are the features. Let's create those labels around it and try and identify it. So model worked beautifully. And then it evolved to a place wherein if there is a silhouette, it was not able to understand. You can see my silhouette. How do you say that this silhouette here is Rohit Chugh? You cannot say that. So that is where machine learning actually stepped back, and the data scientists came up with neural networks, wherein they identify patterns completely the way humans think. That is where the vision is going today. So this example in the nutshell was about how data leads to machine learning, big data leads to machine learning, and then with neural networks, you can go actually into the AI space. Today, if we talk about chatbots, that is a good example of a narrow AI. Why is it a good example of narrow AI? Because if you imagine it that way, there are millions and millions of users using that chatbot with so many different kinds of combinations of natural language. I want to buy an apple. Is that apple a fruit or a watch or an iPhone is a question. So these are some of the other trends that we are also trying to explore: natural language processing, narrow AIs, and stuff. With that, I would like to conclude my talk. Parth, if you have to add anything here, please.
No, I think it was a very informative. Some of the points that you were talking about, Rohit, were also very informative. I hope the audience also enjoyed the points that we were talking about as much as we did. So that's what I had to speak about today.
Yeah. Thanks, Parth. Thanks. If you have any questions, I'm outside. We can discuss this offline. Yeah. Thank you.